Hi, we are from At Home Tuition. In this video, we are going to see few examples on how to factorize the given algebraic expression using various identities. Our first question is, factorize a square minus 2ab plus b square minus c square. Solution. See, if you look into the given equation, it has 4 terms, right? 1, 2, 3, 4. So now, let's take the first 3 terms of the given expression, which is a square minus 2ab plus b square. So now we have learned different identities. Now I think this expression suits the identity 2. So we know that a square minus 2ab plus b square can be written as a minus b whole square, which is nothing but identity 2. So this identity 2 suits this 3 terms of the expression. Now we are considering only the first 3 terms of the expression and we are comparing with the identity 2, that is a square minus 2ab plus b square. So we can write this expression as a minus b whole square. Now the 3 terms is simplified as a minus b whole square. Now we are considering the 4th term, which is nothing but minus c square. So now we can reduce the expression like this. A square minus 2ab plus b square minus c square. That's the given expression. Now we are reducing it to a minus b whole square minus c square. So it is difference of 2 squares. So now we know that the difference of 2 squares, that is a square minus b square equal to a plus b into a minus b. That is identity 3. Now we are applying identity 3 because this is of the same type. So we are applying identity 3 for this equation or expression. So now considering, we'll take a as a minus b and b as c, and we are comparing with the identity 3, and we can write a minus b whole squared minus c squared as a minus b plus c, that is a plus b into a minus b. So it's nothing but a minus b minus c. So this is our required factorization because which cannot be reduced further. So this is our required factorization. So notice how we apply 2 identities one after the another to obtain the required factorization. So that is, can apply 2 identities to simplify a algebraic expression. So the factors of a square minus 2ab plus b square minus c square is a minus b plus c into a minus b minus c. Our next question is, factorize m raised to the power 4 minus 256. So now if you look into this expression, we can express m to the power 4 as m squared raised to the power of square, and 256 can be written as 16 square. So now we can compare this expression with the identity which fits to it. So now we know that a square minus b square equal to a plus b into a minus b. That is identity 3. So now this suits our equation, right? m4 minus 256 can be written as m square raised to the power 2 minus 16 square. So it suits our identity. So now we can applying this identity and we can write this m raised to the power 4 minus 256 as m square minus 16 into m square plus 16. So now this term m square plus 16 cannot be factorized further, but m square minus 16 can be factorized further by applying the same identity. So how we can express m square minus 16? It can be expressed as m squared minus 4 square. Again it is of the form a square minus b square. So we can write it as a plus b into a minus b. That is m plus 4 into m minus 4 or m minus 4 into m plus 4. So m power 4 minus 256 can be finally written as m minus 4 into m plus 4 into m square plus 16, because this cannot be reduced further. This is reduced as m minus 4 into m plus 4. See, in this example what we are doing, we are applying two same identity twice. Previous example we have applied two different identities, but here we are applying the same identity twice. Now let's see the next example. Factorize the following expressions: a square plus 8a plus 16, p square minus 10p plus 25. Now let's go one by one. First expression is a square plus 8a plus 16. So first let's observe the given expression. It has three terms. Now look into your first term and last term. Both the first term and last term are perfect squares. Now look into the sign of the middle term. So it is a positive number. So now if the condition is like this, we can express this given equation in the form of a square plus 2ab plus b square. So the condition is first and last term should be perfect square, and this should be either followed by plus or minus in the middle term. So now considering this, observing what we will get, a square, it's a square, and then 16. So b square, it's nothing but 16. So b is nothing but 4. And how we can express this 8a? So it is 2ab. So 2 into a is same a and b will be 4. So 2 into 4 into a will be 8a. So now we can express this by using the identity. We know that a square plus 2ab plus b square is a plus b whole square, which is identity 1. Now we can compare this. Okay, so now a is a and then b is 4. So how we can express this? A plus 4 the whole square. A plus 4 whole square. So that is our reduced form or factorized form. So factors of a square plus 8a plus 16 is a plus 4 into a plus 4. That's nothing but a plus 4 whole square. Now let's see the next example. P square minus 10p plus 25. So if any expression is given like this for factorizing, first you have to look into the first term and the third term, because it has only three terms, first term and last term. Both are perfect squares. Now we have to look into the sign of the middle term. So it may be either plus or minus. So in this case it is minus. So now if it is of this type, we can rewrite the given expression as in the form of a square minus 2ab plus b square. So if you compare this equation with the given, a is nothing but p and b is 25. Okay, so b square is 25 and b will be 5. And then we can express it as a square, that is p square minus 2 into 5 into b plus 5 square. So on comparing with the identity 2, that is a square minus 2ab plus b square equal to a minus b whole square, we can write it as p minus 5 the whole square. So which cannot be reduced further. So this is our final factor. So the factors of p square minus 10p plus 25 is p minus 5 into p minus 5, that is p minus 5 the whole square. Hope you have understood how to do the factorization of the given equation. So first you have to look into the first term and the third term, that is the last term. If it is a perfect square, then you can go for identity 1 and 2. And also what we have learnt here is we can use for a single question 2 identities or 3 identities, or we can repeat the same identity to factor the given expression. Thank you for watching this video.